Imagine the feeling of not recognizing those closest to you, your friends, family, and loved ones all becoming strangers with a lifetime of memories erased from your mind. This is a fear that many people have as they age into their retirement years because of the prevalence of Alzheimer's disease. Although Alzheimer's disease is the most common form of dementia in elderly people, it is still not fully understood and no cure has been found. Alzheimer's disease is typically diagnosed in people over the age of 65. There are 3 stages of Alzheimer's disease. The first consists of mild memory problems, such as misplacing items or repeating questions. During the second stage, memory problems become more severe. Patients typically start to forget family members and may have hallucinations, delusions, or paranoia. In the final stage, patients may suffer from seizures, skin infections, loss of bowel control, and difficulty communicating. This neurodegenerative disease progressively gets worse until the brain shrinkage eventually leads to death. For patients who are over the age of 80, death can occur as soon as 3 to 4 years after being diagnosed. Younger patients usually have 10 years left to live after being diagnosed.
While the molecular pathology of Alzheimer's disease has been studied extensively over the years, very little is confirmed about its ultimate cause. Development of the disease is linked with accumulation of misfolded amyloid beta proteins in afflicted neurons. This may be due to overproduction or failure to degrade these proteins. In Alzheimer's disease, amyloid beta self-aggregates into extracellular plaques. These plaques can have a debilitating effect on neuron function, blocking synaptic transmission, inhibiting cellular proteasomes responsible for the routine degradation of proteins, and inhibiting mitochondrial function. Another molecular marker of Alzheimer's pathology is the accumulation of intracellular neurofibrillary tangles. These tangles are composed of a microtubule-associated protein called tau. In healthy neurons, tau serves to cross-link adjacent microtubules and axons to ensure their proper orientation and stability. Accumulation of amyloid beta plaques is thought to lead to the hyperphosphorylation of tau. This causes tau proteins to detach from the cytoskeleton and accumulate in the cell body, where they form tangles. This process degrades neuronal structural integrity and prevents axoplasmic transport between the soma and the axon terminal. The buildup of amyloid plaques and tangles of tau eventually leads to neuronal cell death. However, much is still to be learned about exactly how this process starts and progresses.
As modern science allows people to live longer than ever before, the threat Alzheimer's poses looms. Incidences of the disease in the United States are expected to triple to 13.2 million cases by 2050. This is not only a threat to people, but also potentially to the U.S. economy. This is because Medicare will most likely not be strong enough to pay for the care these patients need. Another threatening figure shows that Alzheimer's deaths have increased 66% in recent years, while other leading causes of death have all shown decreases in fatalities. As dark as the image painted by these statistics is, there is hope on the horizon. As recently as January 15, 2013, a major breakthrough in the course to an Alzheimer's vaccine was published in the Proceedings of the National Academy of Sciences. A team in Quebec have identified a molecule known as MPL. This stands for monophospholipid A, and what it does is stimulate the brain's immune cells to attack amyloid beta, the main problem causer in Alzheimer's. With continued support from the public and lawmakers, there is hope that future research could yield a cure to one of the world's most prevalent neurodegenerative diseases.